Global warming, the gradual increase of Earth's average temperature over time, has been an issue facing the Earth since the early 19th century. Much of the blame for global warming has been put on the human race's large consumption of Earth's natural resources that create greenhouse gases. This in turn leads to the depletion of ozone, leading to the sun's rays hitting the surface of the Earth with a higher frequency. A primarily affected location for the rise in Earth's climate is the Arctic region of the Earth. Average temperatures in the Arctic are currently growing at a much faster rate than everywhere else in the world, while the surface area of sea ice is falling. This means that the average temperature of the Arctic has steadily been rising since 1900. The landscape of the Arctic consists of large chunks of frozen sea ice floating in the ocean. Although there is no human population in the Arctic, human impact has extended and affected the Arctic greatly. The Arctic covers 5.5 million miles with an average summer temperature of -10 degrees Celsius and an average winter temperature of -90 degrees Celsius. Because a recurring theme of Earth's paleoclimate history is the importance of the Arctic atmosphere in helping to regulate the global climate on several spatial and temporal scales, the ecological consequences of Arctic sea ice change could potentially be devastating to the biome. Additionally, the value of exporting fresh water from the Arctic is essential to the regulation of global ocean circulation patterns and climate. More recently, historically unseen changes have been found in the Arctic as an effect of climate warming. Effects include increased precipitation, river discharge, and glacial sea ice melting. This being said, the consequences of changes in the Arctic Sea could be catastrophic not only to the biome itself, but on global patterns and climate on the whole. Although the cause of global warming is highly debated, it is known that climate change is the result of both natural causes and man-made causes. Natural causes include those that occur as a result of natural anabolic reactions, such as the release of methane gas from beneath the tundra into the atmosphere. Natural causes are completely uncontrollable and have occurred continuously since the beginning of time. However, man-made causes are the most destructive. Pollution, industrialization, and globalization all contribute to man-made causes. Of these causes, pollution is the most prevalent. With the rise of industrialization across the globe, factories burn an excess of fossil fuels that release the greenhouse gas carbon dioxide into the atmosphere. Carbon absorbs lighted energy from the sun and converts it to heat energy, causing an increase in temperature. This is referred to as the greenhouse effect because, similarly to a greenhouse, carbon dioxide lets the energy in but doesn't let all of the heat energy out. Industrial powerhouses, including the United States, China, and India, release more than 500 million metric tons of carbon into the atmosphere, and in doing so, they contribute to the greenhouse effect and global warming. At the rate of current carbon pollution, it is estimated that the average temperature will climb 2.5 Celsius degrees. Although this doesn't sound like much, these few degrees could cause glaciers to melt. Government-mandated recording of sea ice began in the late 1970s with the use of satellites, ships, and aircrafts. In the early 1980s, the volume of ice in the Arctic measured between 20,000 and 30,000 kilometers cubed. 4 decades later, in 2013, the ice's density spans a mere 3,000 cubic kilometers during the summer months. The mass of sea ice also keeps the polar regions cool. Moreover, as the ice continues to be diminished, instead of reflecting the sun's rays back towards the sun, the ocean absorbs the rays in the form of heat, warming the ocean and accelerating the process of global warming. As a result of the melting ice and decreased ice volume, ocean temperatures rise and become less able to absorb carbon dioxide. As a result, the natural balance of carbon dioxide is offset, causing problems to organisms and the atmosphere as a whole. On the surface, this problem doesn't seem to present any pressing problems besides rising ocean temperatures and ice loss. However, when further examined, it is clear that this drastic decrease in ice presents a much larger impact on the Arctic biome. In the Arctic, 4 massive ice shelves have broken away as a result of climate change. These include Isles, Searson, Markham, and Ward Hunt. Collectively, in these 4 shelves dwell hundreds of species, many of which are dependent on the ice. Walrus, seals, and polar bears are just 3 of the many species that are slowly losing their homes to climate change. It is estimated that there are 20,000 polar bears living of the near 45,000 that were alive in 1980. This being said, in 2007, the National Wildlife Federation placed the polar bear on the list of endangered species. Ice loss presents very large problems to these species. The existence of ice is the foundation for many Arctic species' necessary functions. Primarily, as ice density decreases, mammals' access to reliable sources of food is diminished. As a result, adolescent species often become the victims of cannibalism. Moreover, drowning has become much more of a pressing issue. The demand values in reference to conservation of sea ice is that it is essential to the human survival and general well-being of Earth for sea ice to be conserved. What this means is that in order for the human race to continue life as it is, it must change its habits to conserve sea ice. Relating intrinsic value to Arctic sea ice is that without it, there would be a large backlash regarding global climate and sea levels. Intrinsic value is simple in that without sea ice, every climate located on Earth would change vastly to be warmer than it currently is. The value of sea ice is transformative because it is not widely recognized the vast effect the sea ice had previously. Due to a rise in the average temperature of Earth, warm ocean currents are being sent northward to the Arctic Ocean, melting the sea ice, causing there to be less surface area of ice to reflect the sun rays, making the Earth warm. Therefore, ice has transformed into now a very valuable asset to Earth. Like any biome, the Arctic Sea is host to a plethora of species, including mammals, marine life, and birds. Because of the omnipresent freezing temperatures and thick sheets of ice, organisms living in the Arctic region rely on the ice for shelter and as means of staying afloat in the sea. Because the Arctic temperatures have recently become warmer in the past 30 years, organisms will be forced to adapt and adjust to the warming temperatures. While this may not seem significant, if the ice begins to melt, problems may arise as organisms dependent on the ice will need to seek new alternatives. Changes in Arctic sea ice undoubtedly affect the region itself. The effects on a global scale could be equally catastrophic. The Arctic atmosphere plays a pivotal role in the regulation and the global climate on spatial and temporal scales. Significant changes would disrupt patterns and could be disastrous to the Arctic region and other regions dependent on the Arctic. Increased precipitation, river discharge, and glacial and sea ice melting would severely alter the biome. Modal shifts in the atmosphere have significantly altered the Arctic Ocean's circulation patterns and distribution of freshwater into the Atlantic Ocean. For this reason, the changes in sea ice in the Arctic Ocean could severely alter global sea and climatic patterns. Because humanity is largely responsible for global warming, and thus the effects of global warming, we are indirectly causing the depletion of Arctic sea ice. The evolutionary golden rule of cooperation asserts that we must cooperate with nature and respect the natural world, and in turn, nature will maintain equilibrium. Currently, humans are not cooperating with the golden rule, and as a result, we are experiencing negative ecological ramifications such as climatic change.